The second question is an identical objects question that is more disguised. It's not as easy to see that it's an identical objects question. Because Graham is walking 8 blocks from his home to the library. He always walks 4 blocks east and 4 blocks south. I'm going to draw a picture of this city grid here. There we go. If he's walking south and east, this is his home is here, and the library is down there. So one example of Graham going from his home to the library, he could go like this, and then like this, and then like this. And we're assuming that Graham is an intelligent boy, and if he's going to the library, he doesn't do stuff like this. Going to the library, ooh, where's the library? I don't know where the library is. Whoa, that's close. Got there. Okay? We're assuming Graham is smarter, and he always chooses a pathway that will get him closer to getting to the library. So one example is this blue one. And you could do this by going east, east, then south, 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 and then east, east. That would be one example. And now maybe you start to see where the Mississippi part comes into play. Because if I arrange where the south is and where the east is, that'll make a different path. But just switching up the souths in the middle wouldn't make anything different. So we have some identical objects here. And the total number of ways that Graham could get from his house to the library would be 8 factorial over 4 factorial for the e's, 4 factorial for the s's, which would give you 70 ways. I'm going to show you another way that you can count this. Okay? You could be systematic. Graham's starting there. If he wanted to get to this corner, does it make sense that there's only one strategic way to get there? Any other way would backtrack. If he gets there by doing this, he's having to go back north. It's a waste of time. In the same sense, there would only be one way to get to that corner. How many pathways are there to get to here? Is still only one. There's only one route. There's 2 roads, but that isn't a path. Like, there's only one route to get to this spot. Does that make sense? The only way to get to that spot is straight. Any other way that he gets to that spot would cause him to backtrack. Same thing, 1 and 1. All of these ones will be 1s. But now if we take the next closest point there, and you say, how many ways could you get to that spot, being efficient, never backtracking? There'd be 1 way this way, and 1 way this way. Does it make sense that that would be 2 for that number? And for this one, there'd be 1, 2, 3 rows. And by symmetry, this one will be 3 as well. Now I'm going to tell you some more numbers. You could count them. You could figure out this was 4. You could figure out this was 5. This was 4. This was 5. And you could count them and figure out this is 6. I want you to see if you notice a pattern and tell me how many ways to get to there. 10. Excellent. Why is it 10? Well, the only way to get to that spot, you would either be coming down from here or over from here. Does that make sense? The only way to get to that 10 is by going down from the 6 or over from the 4. And if there's 6 ways here and 4 ways there, we add them together to get 10. Similarly, this will be 10. 10 plus 5, this will be 15. Technically, you could do that for the 1s as well, right? How do I get to this spot? Well, there's no ways that I can come down, because there's a 0 there. And only one way that way, so that's why it stays a 1. And 10 plus 10, this will be 20. 10 plus 5, this will be 15. 20 plus 15, 35. 35, 35 plus 35, 70. We get the same number. Now, the factorials and the identical objects is better in this example, right? Because it was quick and easy, right? But this counting method might and would be better if all of a sudden, right, there's his house, there's the library, but in here is a big lake. And Graham doesn't know how to swim. Now how many ways can he get to the library? Now we're going to have to use, okay, 1, 1, 1, 1, 1, 1, 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 3, 4, 5, 5. But now this spot, he can only get to there from this way, not from the water. This will still be a 4. And same thing, this one only down, this will still be a 4. 5 plus 4, 9, 4 plus 4, 8, 9, 17, 17, 34. If there was a water hazard on his way to the library, then he would only have 34 routes, and you would have to use the counting method and couldn't use the identical objects in the same way. Okay, question for practice on this one is number 12. And since these are all